Okay, so finally we're going to look at the integrated rate laws for zero or second order equations. All right, I'm going to do one for each, one second order and one zero order. But remember, just like the last time, there may be variations. Okay, one may ask for seconds, one may ask for the final concentration, one may ask for K. All right, so I'm not going to do one of each like I did last time. I'm just going to do the one, and I'm going to trust you can figure out how to rearrange the equation to solve for the other one. All right, so the first one we're going to look at, it says, I'm taking this directly from the homework, the gas phase decomposition of nitrosyl chloride at 400 degrees Kelvin, and then it gives us that equation, NOClG, arrow sign NOG, plus 1 half Cl2G. Now remember, we can always forget the first two lines because they have nothing to do with what we're trying to look for. All right. So we move to the third line. It says is second order in NOCl. All right. So this is a big change because before we were only looking at first order equations, right? This stuff right here. But now we're looking at second order, which is a different equation. All right. So don't use this equation, the first order equation, for second order problems. Use the second order equation for second order problems, and so on and so forth with zero. All right. So it says a second order, and then it says in one experiment, when the initial concentration of NOCl was 4.98 times 10 to the negative 2. All right, I'm going to stop right there. So you notice it already gave us something. What did it give us? The initial concentration. It says in one experiment, when the initial concentration of NOCl was 4.98 times 10 to the negative 2. All right, so if we look at our equation right here, we see that the initial concentration is right here on the right side. All right, so I'm going to go ahead and plug that in. All right, so over here on the right side, we're going to add our 1 over the initial concentration, which it says is 4.98 times 10 to the negative 2. All right. So all I'm doing is I'm taking this directly from this equation right here. You see how it's 1 over the initial concentration? Just the same, 1 over the initial concentration. All right. And that's a 4, by the way. Sorry, it's a little unfocused right now. All right. Now let's keep reading. The concentration of NOCl dropped to 1.27 times 10 to the negative 2. All right. It dropped. So that means it gives us the final concentration. All right, now if we look back and see where our final concentration is, it's right here on the left side. All right, you see this 1 over the final concentration. So we're just going to do the same thing we did. We're just going to plug it right in. So it's 1 over 1.27 times 10 to the negative 2. All right, because 1.27 times 10 to the negative 2 is what it says is the final concentration. Now, a quick thing to note, anytime it says the concentration drops to something, or the concentration falls to this, or will be this, right? Remember, will be was the phrase it used in the last one. Anytime it uses a phrase like that, oh man, come on, focus now. There we go, that's better. Anytime it uses a phrase like that, we know it's talking about the final concentration. All right, so just look for that. Now let's keep reading. After 6.72 times 10 to the negative 4th seconds have passed. All right, then it says based on this data, the rate constant is what? All right, so it just gave us one last piece of information, and that's t, the time right here. All right, now notice there's no negative sign here like there was in the last one, so you don't need to put that in. But it does give us t, and it says we're solving for the rate constant. So we're solving for k, we're looking for k. It doesn't give us k. So what we're going to do is we're going to put this k right here because we're solving for it, right? And then times k, we're going to put the time, which is what it gave us. 6.72 times 10 to the negative 4 seconds. All right, 6.72 times 10 to the negative 4. Now, all you're going to do is simple algebra, all right, just like we did last time. So the first thing I like to do is I like to subtract this from both sides to get my k by itself. So on the calculator, what I do is, clear all that, 1 divided by, now this is the left side, okay, 1.27 times 10 to the negative 2, all right, minus 1 divided by the right side, all right, which is 4.98 times 10 to the negative 2. Oop. 10 to the negative 2. There we go. All right, so all I did is subtract this from both sides. So basically, I took this fraction, and I took minus this. All right, so this fraction minus this one. Got it? And I put that in my calculator, and I get 58.66 rounded. All right, 58.66. All right, is equal to k still times this number right here. All right. Now, all you do to find k is you just divide both sides by this right here. All right, 58.66 divided by 6.72 times 10 to the negative 4th. So we're going to find k to be, you just plug it into your calculator, 58.66 divided by 6.72 times 10 to the 4th is 8.7 times 10 to the negative 4th. All right, 8.7 times 10 to the negative 4th. And that's your answer. All right, so that's the problem that we're going to do for second order.